Okay, so we're back with the last part of the analysis where we're going to look at the main effects and the interaction effects in more detail. So this is the fun bit. I know you're thinking it couldn't possibly be more fun than it already has been, but I like this part where we get to make some graphs that really show us what our conclusions are for this analysis. So we're going to start off with the main effects, and we had this line in the GLM output that told us that there was a difference between the types of sodas, but it doesn't tell us which ones are different from each other. So what we're going to do is we're going to run the analysis again, and this time we'll tick the multiple comparisons box. So I'm going back to general linear model. There's my model in there again, and for comparisons we're going to do some pairwise comparisons for type of soda, and you can do these for the height of drop and the amount of BCS as well. I'm going to leave the confidence level at 95%, but you could bump that up to 99 if you wanted to. And I do want this grouping information. I think this might be new. I don't remember seeing this on old versions of minitab. Having said that, the very first version of minitab I learnt was command line interface. And it didn't have any menu options at all. So there we go. Let's have a look at that. I don't need to see the residuals again. I've already looked at those. So we have here the grouping information that I used in the overview animation of this project. Grouping information using Tukey's method and the 95% confidence level means that do not share a letter are significantly different. So what it's saying is that lemonade is significantly different from Coke and orange, and Diet Coke is different from all the others, but Coke and orange share a letter, so they are not significantly different from each other. Now this by itself is really quite boring, and we can do a little plot to show this, and there's a couple of different options for showing your mean effects. We can go to stat ANOVA main effects plot. I'm interested in height and the type of soda. Now, the reason it's not showing anything is because I keep messing around with all the colours. And I'll spend hours trying to work out exactly which default option was the points on this particular plot, and I could not work it out. So if you can see here, there's 4 little dots have turned up, and that's my group means. If I just double click those, I am going to change those to red, and I'm going to make them nice and big because that's the way I like my plots to look. And there is actually a line joining these. If I can select that as well, there we go. Oh, I think that's a line joining, yep. And let's make it green and that big. Beautiful. So this is showing us the means for the different types of soda. So we can see here why Coke and orange were not significantly different. They're really quite close together. And this reference line across the middle here is the overall mean height of fizz, and these are the group means. And we can see Diet Coke was low, which is what we would expect from the scatter plot that we did, and the lemonade is high. So you can do this plot straight away without doing any analysis, but what you won't know is whether or not these are statistically different from each other. Depending on the Y scale, some things can look significant when they're really not, and we'll go over that a bit more in the interaction plots, because that's where it often looks like you've got something really impressive going on, but it turns out it's not significant at all, and it was just this Y scale zooming in making it look better than it really is. There's another way we can draw this plot. And if we go to ANOVA, just above the main effects plot, you can draw an interval plot with groups, height, type of soda. Okay. So what we have here is a confidence interval for the mean. Now the way statistics works, again this is a little bit backwards, but we assume that there is a true value for the mean, say, of Diet Coke, and we are going to estimate what that true mean is with our confidence interval, and the confidence interval tells us that we can be 95% sure that we have covered the true mean with our interval. It doesn't actually mean that we're 95% sure that this dot in the middle here is our true mean. Something that might be nice to add to this plot are some reference lines. Now what you can see with this Tukey's test was done at the 95% level, and these are 95% confidence interval for the means. And so what you find is if the confidence intervals don't overlap, then that means the group means are significantly different. We can see here that, again, that Diet Coke and lemonade are completely separate and there's no overlap in the means. So these are mean estimates. This is not the whole distribution of results. So it's tighter than if you just did a dot plot of all the results for height. And something we can add in are some reference lines just to check to see what's overlapping here, because it's a little bit difficult to tell if these two overlap from this graph. So that tells us the interval goes from 74.7 to 95. So I'm interested in that lower boundary of 74. And this one here goes from 84 to 100. So I'm interested in this line at 74 and this line at 100. And I'm going to put in some reference lines. So I'm going to right click on the graph, say add reference lines, and it was 74.7, I think. I have a 2-second memory, so I'll get these wrong. And 100. Maybe I should have written it down somewhere I could see it. Okay. That's pretty close. So now that we've got the reference line in here, if I make that big, we can see that Orange and Diet Coke, the confidence intervals don't overlap at all. So at the 95% level, we can say that they are significantly different. Now, it may happen that if we bump that up to 99%, they would overlap. So that would mean at the 99% confidence level, we couldn't be sure that they were different. And the lemonade is way above the others, so that's different. So you've got a couple of options there for showing what your main effects are. Either way is fine. You probably don't need both. And the next thing we want to look at are the interaction effects. So if we go back up to our GLM, and I'm talking here about this line here, type of soda times height of drop. So the null hypothesis, just to recap, is that there is no interaction. We have a very low p-value, so that's strong evidence to reject the null hypothesis, telling us that there is some kind of interaction between the type of soda and the height of the drop. It doesn't actually tell us what that interaction is, and so to tease that out, we'd want to do a plot. So I'm going to go back up to stat, ANOVA, interactions plot. Height, type of soda, height of drop, and you don't actually need the star in between them for this one. Now, what I would like to compare this with is the scatter plot that we did at the start, just to point out something you need to watch when you're doing interaction plots. In this case, because our four groups were quite different, the reference lines here are quite spread out. But these points here represent group means, they don't represent data points. And your group means are always going to be inside the range of all your data. And what minitab does is it rescales the y-axis just so that it's got enough room to show the group means, not to show all of the data. So sometimes it can look like you have a significant interaction here just because you've been zoomed right in on the y-axis. I would recommend that you take a look at the scale of the interaction plot at the same scale as your scatter plot, or what you've been using for the other plots. So if you just double click on that, you'll see that minitab has auto-calculated its min and max, and I would like the min and max to match up to what I have on my scatter plot for comparison. So I'm going to set that down to 25. I could set it all the way down to 0, but this one only looks to go to 25. And I'm going to set the top one to 175. And now you can see that it doesn't look quite so impressive. But that's why interaction plots can sometimes be misleading. It can sometimes look like you've got a really big effect going on, and actually it's not significant. So you always, always, always must go and double check your output to see what the p-value is before you get too excited about one of these plots. So what this is saying is, for the Coke and Diet Coke, they had an average fizz height down here for when the bicarb was dropped from 80 millimetres, but the fizz height for both of them went up when we dropped from 180 millimetres. For orange, the amount of fizz actually decreased slightly when the bicarb was dropped from higher up, and the drop height didn't seem to make any difference at all to the lemonade. The lemonade just fizzed a lot all the time. And so because the height of the drop of the bicarb is having a different effect depending on which type of soda it is being dropped into, we call that an interaction effect. And we can do those interaction plots for the other interactions in the output as well. You'll see that they were all significant in this case. Type of soda times bicarb and height of drop times bicarb.